Alright, ladies and gentlemen, this is A2 Notes Arc Central Angle. This is going to be a multi-part video here, because there's going to be lots of information that we're going to be going through. Your objectives: you'll be able to identify central angles, major arcs, minor arcs, semicircles, and find their measures. You're also going to be able to find arc lengths. Alright, so let's go through some of this stuff here. A central angle of a circle is an angle with a vertex in the center of the circle. So that vertex, the point, that piece there, it has to be the center of the circle. So B is literally the perfect center of this circle. So central angles require that. There needs to be a point in the middle of that circle. Its sides contain two radiuses, or radii to be technical. So BA is a radius and BC is a radius. So the requirements of a central angle, just to recap: there needs to be a point in the middle of the circle, and then from that radius there needs to be two, so from that center of the circle there needs to be two radius, so BA and BC, in order for it to be a central angle. Now angle ABC is a central angle of circle B. Now every 1 degree is 1 over 360th of a circle. This leads to the following relationship. So let's give you some more information here. The sum of central angles. The sum of measures of a central angle of a circle with no interior points in common is 360 degrees. For example, we see this circle over here. Central angle 1, aka that red angle, plus angle 2 here in orange, plus this green, angle 3, the red plus the orange plus the green equals 360 degrees, because there's 360 degrees in a circle. So if we had angle 3 was considered 60 degrees, angle 1 was considered 200 degrees, and we had to find that last angle to make the 360. All we got to do is 360 minus the 60 minus the 200. So this orange one would have to equal 100 degrees, because all three of these angles have to add up to 360 degrees. That's what this is saying here, the sum of central angles. So now an example, once again, here's another one. So this orange angle is 130 degrees. This angle right here, I'll make it red. We see that there's a little 90-degree box, so that red angle is 90 degrees. Find the value of x. So to find that value of x, we do 360 degrees minus the 90 degrees that's given to us, and minus the 130 degrees. And when we do that in the calculator, we're going to get 140 degrees left. So that green angle, or where that x is 140 degrees. Here's another two examples you could practice on your own. Try them first, and then let's see if you get the same answer as me. Now, we know there's 360 degrees in a circle. So we do 360 minus the 145. 360 minus 145, I put that in the calculator. 360 minus 145, get you 215. Now 215 minus 165, get you 50. So the value of x for 1a is 50. That's how many degrees? 50 degrees. Looking at 1b, if you haven't hit the pause button and try it on your own first, why don't you hit the pause button? But I'll do it right now. So there's 360 degrees in a circle. Remember, this little red box means 90. So 360 minus 85 minus 40 minus 90, that's going to get us our answer. So I put that in a calculator: 360 minus 85 minus 40 minus 90, and that's going to get us 145. So that x degrees is 145 degrees. If you got it right, good job. All right, so here's some more practice. See, it looks like what you're going to see on your Google form. So we got this circle. We got 4 points here, A, B, and C on the circumference, and D is the center of the circle. This red line here is the diameter. It goes through the center of the circle. Now, we talked about there's a 360 degrees inside of a circle. Well, the diameter chops a circle in half. So you got to ask yourself, well, what is half of 360? Well, half of 360 is 180. So on one side of this diameter, there's a total of 180 degrees. To find the value of x, we do 180 degrees minus that given 84. So 180 minus 84 gets us 96. So the value of x is equal to 96 in this problem. Let's try another one. We know that there's 180 degrees on one side of the diameter. We want to find this value of x, so we do 180 minus 122. (180) minus 122 gets us 58, so x is equal to 58. Let's try another one. Now this one's a little bit more complicated because now there's 3 central angles. Not a big deal because you guys know there's 180 degrees on one side of a diameter. So we got 180 degrees in total, because that's how many degrees are on one side of a diameter of a circle. So we do 180 minus 43 minus 57. 57, not 67, 57. So 180 minus 43 minus 57, which gets us 80. So the value of x is 80 for this little angle. Just in case if you don't really see it, the value of x is that blue angle right there. And that's going to be 80 degrees. Alright, let's try another one with 3 central angles. We know that there's 180 degrees. Well, let's leave it in blue. There's 180 degrees on one side of a diameter. And because of that, we do 180 minus 59 minus 18. We put that in our calculator. 180 minus 59 minus 18. We're going to get 103. So 103. And that's the value of x, 103 degrees. Now, even if the circle's rotated around a little bit, we still have 3 central angles. Not a big deal because we still do 180 degrees. Because there's 180 degrees on one side of a diameter. So we do 180 minus 44. And then minus 69. And we're going to get 67 degrees. Hopefully you're feeling pretty good about this. Why don't you try this one on your own? Make it a little bit bigger just in case. We got 180 degrees on one side of a line. This is a 48. This is a 47. So we do 180 minus 48 minus 47. And we get 85. So the value of x is 85. Alright. Let's try one that's a little bit different. It's a little bit more complicated, but I think you can handle it. We got to remember a little bit from about 5 minutes ago. We talked about how many degrees are in a circle. Well, this point here in the middle is our center of the circle. There's 360 degrees inside of a circle. So that means these three angles added up. We take 360 minus the sum of those three angles, and we're going to find that last angle, that last central angle. So we do 360 minus 77 minus 69 minus 110. And we're going to get a total of 104. So the value of x is 104. Let's try another one. Then I believe we'll be able to move forward a little bit. So you have that same concept that there's 360 degrees inside of a triangle. Inside of a circle. So that's 360. That's the fact that you just have to memorize. We do 360 minus 64 minus 67 minus 86. So 360 minus 64 minus 67 minus 86. And we're going to get a total of 143. All right. Looking at this problem. An arc is a portion, I'm sorry, not a problem. This is just more key information for us. An arc is a portion of a circle. Make it bigger. There we go. An arc is a portion of a circle defined by two endpoints. A central angle separates the circle into two arcs, with the measures related to the measure of the central angle. So what this is saying is this. We have a circle. Let's make this bigger. There we go. So we have a circle. We have QR as a radius and QP as a radius. When you have one central angle inside of a circle, it makes two arcs. It makes this blue arc, R, all the way down to P. And it makes this red arc, P, all the way to R. That's when you have two radiuses or one central angle. It creates two arcs, one red one and one blue one. Now it's tough because there's only two letters and naming the arc and which arc you're going to be talking about. That's why our naming is going to be very important. Where we have two different names. One called the minor arc, which is the smaller red one. So the smaller one is called the minor arc. The bigger arc in our circle is going to be called the major arc. So looking at this, a minor arc, just like we talked about, was the smaller arc, AB. The major arc is the bigger one in the circle, or the longer path. The major arcs are represented by three letters. We tend to have to throw another little dot on the circumference of the circle to say the direction. So a major arc, ADB. And to find that, you could do 360 minus the little baby arc to find a big arc. That's one way to find if you have problems, which we're going to talk more about in a minute. Let's just focus on the definitions actually. The semicircle refers to 180 degrees. So if the arc is not a minor arc, meaning it's not smaller than 180 degrees, and it's not bigger than 180 degrees, it's exactly 180 degrees, and it's considered a semicircle. So let me recap that. Minor arcs are always less than 180 degrees. Major arcs are always greater than 180 degrees. In semicircles, their arc is exactly 180 degrees. Alright, let's do some problems with that. They're saying that GKH is 122 degrees. The J is the diameter, so this arc right here is 180 degrees, because we know the diameter chops the circle in half. Well, they want you to find GH. Well, GH is the minor arc, sorry, so the central angle is 122. So GH, that minor arc GH, is going to be 122. because that's what this little arc is. The arc and that length is going to be the same. Now, if we want to find out what the major arc is, which they're asking here in B, it's all a little cluttered here. Meaning we're going to try to find this blue arc, GLH or GJH, either one. To find that blue, we know there's 360 degrees inside of a circle, and we're going to subtract that given angle of GKH, that minor arc of 122. So 360 minus 122, that's going to get us 238. Next in C, they want you to find GLJ. So GLJ. They want you to find, I'll erase this so it's a different color. GLJ is this orange piece. It's actually half the circle. Half the circle, you guys know, is 180 degrees. So GLJ is 180 degrees. Let's break that down. Let's do a couple more of those problems. We're going to skip this one. Maybe not. Okay. So looking at this, let's just find this arc. I'm going to revise the problem a little bit. Let's just find this major red arc. We're going from N all the way down to M. So NPM would be the name of this major arc. Or another name you could name this is NQM. Now to find out that length of the arc, that red arc, we have to do a couple little steps here. We have to know that PM is the diameter, PN is 90 degrees because that's what that little box is. So since that's 90 degrees and this is a diameter, that means this guy is also 90 degrees. Our red arc is 360 degrees minus that 90 degrees. So 360 minus that 90. And that will get us 270. Well, just to confirm it, I'll put it in the calculator. 360 minus 90. That gets you 270 degrees. Okay. Now, congruent arcs. So now a little bit more vocab here. With congruent arcs are arcs in the same or congruent circle that have the same measure. So in this case, they're saying that angle 1 and angle 2, those two arcs are the same measure. They're congruent arcs. All that means, once again, if angle 1 is 50 degrees, a congruent arc means it has the same length. So if angle 1 is 50 degrees, that means angle 2 is 50 degrees. If angle 1 was 70 degrees, the congruent arc of angle 2 will be also 70 degrees. It means it has the same number of degrees. Alright, here's a problem. I could apply to real life here. Since we only got a few seconds left for part 1, why don't you try that problem on your own so you get that experience. Next up will be part 2. Alright, have a good night.